All right, so question A, state what is meant by damping. Do your best, right? The damping is what's, of course, causing this amplitude to decrease like that, right? And remember, for Q factor, right, the Q is about how many times it's going to oscillate before it stops. That's sort of an informal thing, right? For B, calculate the Q factor of the system. We're going to use this formula, right? The Q is 2 pi energy stored divided by dissipated, right? And this is subtopic B4, dissipated. That's such a long word, okay? Now remember that the total energy of an oscillator is 1/2 m omega squared x naught squared, okay? And so basically the energy stored is proportional to x, the amplitude squared, right? So when you do this whole stored over dissipated, what we're going to do is we're going to look at this, read what that level is there, how many centimeters that is, read what this is, and then be surprised when you see in the mark scheme what they think that is, okay? And then what we're going to do here is we're going to set up a thing like this. Q is 2 pi, and then I'll call this amplitude 1, I'll call this amplitude 2, right? So it's 2 pi, and then you just go the original amplitude squared over the original amplitude squared minus the second amplitude squared, right? Which is basically, this is proportional to the energy stored, this is proportional to the energy dissipated, okay? And I'll tell you that I got a number between 10 and 11, okay? And then they say the Q factor increases, right? Well, remember, if the Q factor increases, the damping decreases. So talk about how that graph's going to change. See if you can get two different things that you can say about that.